Today we're going to look at learning word vectors in GenSim. So if you have text from a particular domain, like legal documents, you'll want to learn your own word vectors so that the meaning in those vectors represents the kind of text you see. And we're going to do this in GenSim. So there's some documentation for training word vectors in GenSim. The way it works here, Word2Vec. There is a GitHub for GenSim, which often is the best place to go because you'll be able to look right at the source. The documentation sometimes doesn't always have what you want. You can go directly to the GitHub and look at the code. And here is the GitHub part for Word2Vec. There's also some blog posts around like this one. So these will give you some other places to look at. So let's start here. We've got our raw documents. I love tacos. She ran with the chicken. I don't choose to take a nap. The nap chooses me. The man is nice as pie with ice cream. This pizza is an affront to nature. Load up our documents here. What we're going to do next is put those into sentences. So we defined the get tokens function in the previous box. So we're just going to tokenize. So each document is going to be a list of tokens. And then we're going to put it into GenSim Word2Vec model here. So we specified the min count. So that's the minimum number of times a token has to be in the corpus to be used, and the size 5 of vector. So afterwards, we print out ran, love, and tacos. And of course, we get our lemmonization error here because we haven't installed pattern. So we have ran, love, and tacos. And so each of these is listed as a vector. Generally, our vectors are going to be between 50 and 300, but we just make them 5 here just so we can see them. And so in our model here, we can look at the keys, the vocabulary, first 10. Here we are. And so what we can do is we can say, okay, give me the most similar to a particular word. So here we have tacos, and given everything it's learned from the corpus, which in this case is not much, we get the most similar words. Now, of course, these words aren't similar to taco in a cosine distance. What they do is they take the cosine distance between two vectors, which is like the Euclidean distance, but works well if the vectors have different magnitudes. But we don't have enough training data here for these word vectors to really make sense. So what we're going to do is we're going to train in this video on 2 different larger corpuses. So one thing we want to do is in GenSim, you want to make sure that you're running C underneath, and it takes care of that for you, but sometimes there can be a problem. You have to go deal with it if there is. Run C underneath just so it's a little faster. Okay, so the first corpus we're going to use is the 20 newsgroups corpus, and we're going to get that from sklearn. So let's take a look at that. sklearn is a Python library. Here we are, the 20 newsgroups corpus. Got your documentation about it. So we're going to fetch it. And this just gives us the high level of what is this text, description, data. So we can look at the file names that it downloaded and then put it here in users JMugen sklearn data. We can look at how many different entries there are. So what we have is 11,000 or so different posts in news groups. One thing this data set can be used for is classification. So you want to classify, what is this about? Is it about atheism? Is it about computer graphics? Is it about MS Windows? And you can look at, of these 11,000 documents, you can teach a computer to classify them. And we're going to look at that later in a different video. But in this case, we're learning word vectors. Put the data in the data here. And let's take a look at the first post here. All right, looks pretty ugly. Just guy talking. And we're going to define our get tokens here. And we're going to look at the first one. Okay, so this makes a little more sense. We've got a list of tokens for this document. And so what we want to do is create a list of tokens for every one of these 11,000 documents. We'll do that here, so we'll just call them sentences. Get tokens doc for doc and data. We'll print out the first one. So it has a loop through all 11,000, tokenize them, and put them into this data structure here. And what we're going to do next then is pass this set of sentences, quote unquote, which in this case, each sentence is a post, it's not a sentence. Each word has to be seen at least 3 times, and we're going to make the vectors of size 200. Okay, here we are. Now let's train our model. So the model is trained. Let's look at what is most similar to man, and hopefully it'll make a little more sense than when we did that before, when we had just a very small set of sentences. So we get the most similar to man is woman, father, Christ, God, Son, Jesus. And this is making sense. And there's a high religious element here because 1/20th of the corpus roughly is about religion. So let's try a different corpus. Let's try the text8 corpus. And GenSim has some built-in ways of handling this. First, you go and download it from this location. And then you can load it up. I downloaded mine there. So what we're going to do is we're going to train another model with our scents that have been loaded directly from GenSim. Each word has to occur 5 times. The length will be 200, and we're going to iterate over it 15 times. You can specify how many epochs to go through the data training them. So now we can look at the words most similar to man. We get woman, men, person, girl, boy, creature, gentleman, stranger, thief. So even though God does follow at the end, it's not as prominent because this is a different data set. We can also look most similar to happy, quiet, lucky, merry, laugh. That seems to make sense. So we can do the analogy we saw earlier. King minus what is similar to man minus woman. And so we want to find what that what is that fills in the analogy. And we see that queen is indeed the most likely answer. Okay, so now as a bonus, we're going to do something called Doc2Vec. And Doc2Vec learns a dense representation for a document. So we've been learning dense representations for word vectors. Now we're going to learn a dense representation for documents. We need to use this thing called tag documents, and you can get more details here. So we use this thing called tag documents. We're going to get our sentences again from Newsgroup, and we're going to loop through those sentences. Now, these are not sentences per se. These are entries in the Newsgroup. Each one's multiple sentences in reality. So for each sentence, we're going to create a tag document that has both the text and a label that'll be sent underscore with the number. And then we'll train on those documents. And so what it's doing is it's using the tag as another word in the corpus, and it's saying, okay, given this new word, call it a tag, can I predict the words in the document? So the model has been trained, and now we can say what is most similar to the word fast. And we get a bunch of words. Now the training worked very much like it did for the word vectors, except that it added this extra wrinkle of learning document vectors as well, where each document vector has a name sent underscore with its thing. So here we can create a new document, I love tacos, split, put it into a list of tokens, and it'll give us a vector for that document. And since we specified here a size 300 for the vectors, we have a 300 dimensional vector that represents this document. And now we can say, well, what is most similar to that vector? And see, we get a bunch of documents that are most similar. So as an exercise, you can compare this method of creating document vectors with the TF-IDF method that we did previously. So you could find a set of emails or sentences within an email, and you could say, give me the most similar email or the most similar sentence to this particular email or sentence. And you could do that with both Doc2Vec and TF-IDF. It'd be interesting to see which one works better. My intuition is that if you don't have a lot of training data, TF-IDF will work better, but as a corpus gets bigger, then you'll be able to use the power of generalization that comes with Doc2Vec. And so what we've done today is we've learned our own word vectors on corpuses that we downloaded so you could use your own corpus. And we've also learned document vectors.